All right, 4.1, it says ratios within similar parallelograms. Okay, let's erase all this. You can think of the original as mug, and if you use one of these two items on a computer and you scale it inside or outside, it ends up being too skinny or too wide. It looks a little weird. Okay, if you want it to stay the same shape or the same look correct, I guess you could say, usually you'll pick a corner and go inside or outside, maybe this corner, okay, and you have to scale them correctly so it changes the X and Y, or the X and the Y equally, okay? So the one that matches is our right. That's this one down here. Let's highlight this one, and the original are the ones that are similar to each other. Now they have this last column here, height to width ratio, and that is 10 to 8 and 5 to 4. What you know is if you do 10 to 8, is that equal to 5 to 4? Those are, that's a proportion. Okay, they are proportional. Okay, proportional, and that means they are equal ratios. That's what proportional means. Equal ratios. Now, they went within the shape. They said that this was 10 and this was 8 and this is 5 and this is 4. Okay? They compared these two together. Okay? They're just comparing ratios. Previously, in our other lessons, we've been going this way. Times 1 over 2, and that should be the same this way. Times 1 over 2. That's our scale factor. Now we're just comparing the ratios within the shapes themselves. We're just comparing this way and this way instead of this way to this way. We're not comparing image to pre-image here. Okay. Now, which rectangles are similar? So I'm going to have, I'm just going to keep it the same like they did over here, height to width. I'm just going to say long side over short side. Long side over short side. Okay. And for shape A and for shape B, C, and D. And whichever ones are equal are the ones that are going to be similar to each other. Okay, so I'm going to highlight each side. This is my long side. This is my long side. This is my long side. Again, we're talking about corresponding sides, so we have to make sure that we are getting the long side of each triangle, and those are supposed to be red. Let's fix that. Those are all supposed to be red. Okay, and my short side, which is 12 here, 9 here, 6 here, and 6 here. Okay, so let's do, since I got the blue pen, short side of A, which is 12. Short side of B, which is 6. Short side of C, which is 9. And short side of D, which is 6. Okay, my long side for A is 20. Long side for B is 10. Long side for C is 15. And long side for D is 20. All right, I'm going to reduce each one of these because it's kind of hard to tell which ones are the same. So when I reduce this one, I guess I can divide them both by 4. 5 over 3. Divide both of these by, I think, just 2. 5 over 3. These are both divisible by 3. And I'm going to get 5 over 3. Divide these both by 2. I get 10 over 3. So what you'll notice is these three, A, B, C, they all have the same ratio. Okay? They all have the same ratio of long to short. Okay? Long to short. 5 over 3. Okay? Those are all going to be similar. And if you don't remember your notation, that is their symbol for similar. Not that one. Similar. Okay? You're going to try 2A and 2B Well, actually, we already did that. So we already got all this data, and all this data goes here. So we already did 2A and 2B. We noticed that all the ratios when simplified were the same for A, B, and C, which means they are similar. Okay. It says, what does the scale factor tell you? If we pick 2, I'm just going to pick A and B. So here is shape A, here is shape B, and this one had a long side of 10, this one had a long side of 20, this one had, oops, I got that backwards, long side of 20 and long side of 10, and then we had 12, and we had 6. Our scale factor from one to the next is times 1/2. Okay, what does a scale factor tells you? It tells you the amount of change from one to the next. Amount of change from one to the other. Okay, compare the given information by the scale factor in part 3 to the information given by the ratio of side lengths. They should be the same, but that's actually not very important information. We're going to skip that one. Okay, parallelograms should be the same as rectangles, and they are the same as rectangles because they have similar properties in their side lengths. Okay, short sides should match. Short sides, and they're the same as their opposite sides. Parallelograms are essentially just rectangles that are kind of tilted over a little bit. They don't have 90-degree angles. That's the only difference. Okay, but they share the same properties. Okay. You should do this one on your own. 5 minutes, 10 minutes, whatever it might take. And once you're done, go ahead and play the video again. And then see what you get. Make sure it matches. Okay. All right, so if you've given it a try, parallelogram E, the long side is 10. This one is 7.5, and then G is 6. The width for each one of these is 4.8. Oops, I got that wrong. For figure E is going to be 8, 6, and 4.8. There we go. And then our ratio for each one, let me put my division bar here, or my fraction bar, 10, 7.5, and 6. And then on the bottom, 8, 6, and then 4.8. Okay. We'll find the ratio. This one is 5/4. This one is, if I divide this by 3, this one is also 5/4, and divide this by 4.8 divided by 12, 60, and this one is also 5/4. Huh, interesting. They are all similar. Oh, okay. They all have the same ratio, okay, which is great, okay, but there is one thing that's a little different, okay. If you haven't spotted it yet, it's right here. They all have the same ratio, but this one is the one that's a little bit off, okay. They don't have all the same angles. So these two will be similar, and this one is not similar. Okay, so F and G, because they have equal ratios and congruent angles. Okay. So if we only find the ratio of adjacent sides, two sides that meet at a vertex of a rectangle, the ratio is equivalent to corresponding sides of another rectangle. This one is yes. Are they similar? Yes, they are similar. And the reason why these are always going to be similar, yes, they are similar because the word rectangle, because rectangles have all 90-degree angles. The word rectangle defines a 90-degree angle. Okay, and that is not true. This is the same question, but they're just asking if it's a parallelogram. No, because not all parallelograms have congruent angles like rectangles do. All right, your homework for tonight, I'm going to write it up on the top of the page in just a little bit. Let me double check. We're going to finish page 51. Sorry, not page 51, page 49. We already did one together. 49 and 49 and 51. 49 and 51. Is 51 good? Yeah, 49 and 51. Your homework is page 49 and 51. So homework is page 49 and 51. Stretching and shrinking 3 point, which one did we do today? 3.3 and 4.1. 3.3 and 4.1, pages 49 and 51. And that's due when you return next week. We have 1 week and we have your test. So I see you guys again Monday on the 18th, 11/18. Okay, that's your homework for today. Okay. All right, should be it.